your two-dimensional model pieces, you'll see that they're color-coded and that each element has a specific number of these little dots around it. The oxygens, although they have different overall shapes, each oxygen has 6 dots surrounding the central square. Nitrogen has 5, carbons have 4, hydrogen is 1. As you'll see today, these dots are the way carbon makes bonds with other atoms. The dots represent electrons available for bonding. Those are sometimes called valence electrons. The number of dots is determined by the periodic table. Here's carbon. The Roman numeral above it is a 4. That means carbon atoms have 4 valence electrons, therefore 4 dots able to make bonds with other atoms. Here's an oxygen model. You can see oxygen, Roman numeral 6, 6 valence electrons, therefore 6 dots around the central square. Although you don't have a model for sulfur, it's the same column, so if you imagine this being S with a yellow color, it would also have 6 dots because it's in the same column as oxygen. These are the most common elements found in what are called organic molecules. And so we can make lots and lots of molecules with these elements. Molecules are made by putting these atoms together. The rules are you need to match them up. So if there's, I'm hoping you see these fit together perfectly. This is a molecule. It's a hydrogen atom bonded to another hydrogen atom by sharing a pair of electrons. That's called a covalent bond. It makes a molecule. So H2 is a very simple molecule. The rule for making molecules is that you need to fill all the available bonding spots. So a carbon has 4 available bonding spots. So this is a bond, but it's not a molecule yet. I need to fill all the bonding spots before I can call it a molecule. So that's 3 bonds, but not yet finished. I would need a 4th bond over here. And now I have a molecule. Carbon bonded to 1, 2, 3, 4 hydrogens is a molecule. There is no rule for which element can bond to another. As long as they have dots, they can bond. So you can make really big molecules just by saying, I'll just keep adding to it, keep adding to it, keep adding to it. And as long as you fill every spot, that's a big, complicated molecule. To represent this model structure on paper, we use what's called Lewis dot structures. So I'm hoping when you look at this carefully, you see 4 atoms, H, O, O, and H. And I'm hoping you see that in my example. That structure is faithfully reproduced with H, O, O, H, and dots are used to represent those electrons, so that there are 2 electrons between the H and the O. That's a bond. There are 2 electrons shared between the 2 oxygens. That's a different bond. There's 2 electrons here that are shared. That's a 3rd bond. There are also these other electrons that belong to oxygen. They're not bonding electrons, but they're important. In my example, I'm using an X to represent an electron from the hydrogen and a plain dot to represent an electron from oxygen. That is not essential, but it does help you keep track of whose electrons are whose in the structure. The second kind of translation you'll do is a dot structure to a line structure. Here's the dots. There are only 3 bonds in this molecule, and the line structure will focus on those bonds. There's a bond between this hydrogen and this oxygen. I write that as a line. There's another bond between the oxygen and the oxygen. I write that as a line. There's a third bond between the oxygen and this hydrogen. I write that as a line. So this is a molecular structure that shows the 3 bonds clearly. It leaves out these other electrons that are not bonding. It focuses on only the bonds.
For this assignment, you're going to use a simulator in order to create the Lewis dot structure, and then you'll use the Google Draw portion to create the line structure. So first thing is to open up the simulator, and you'll see the simulator has your atoms at the top, various different types, a clear scene, and a bond breaking energy fire button. So when you're creating atoms in the Lewis dot simulator, you'll first want to pull in the atoms that you need. So I'm going to make the first one, which is hydrogen peroxide, H2O2. The subscripted 2 tells you how many of that atom there is. So there are 2 hydrogens and 2 oxygens. So I'm going to pull 2 hydrogens out and 2 oxygens out. Because we're doing single dots and lines, you're only going to use the single bonded carbons and oxygens. So this carbon here, don't use this one. This oxygen here, don't use this one. And don't use this carbon either. All the other pieces, nitrogen, chlorine, and hydrogen, are okay. So once you have all your pieces out, you can start putting them together. The only rule is that each atom must have all of its seats at the table filled, and when it's complete, you'll hear a chime. So if I want to attach my hydrogen and my oxygen here, in order to rotate the hydrogen, you just have to click it with the mouse, and it'll rotate, and when they bond together, it'll make a sound, a dinging sound. So then maybe I want to try this together, another dinging sound, and then last but not least, I'll attach my hydrogen onto the top. And when it's complete, it'll come up with a little score here. Don't worry about that. And then yours is complete. So then you take a screenshot and insert it into the document. If, for instance, something isn't working out with how you're bonding it, you pull a little fire in and put it on top of the bond that you want to break, and it'll break it apart, and you can change things around. When you're ready to do the next molecule, you can clear your scene, and voila, start over. To change the line structure, you'll need to double click on it, and you can move the letters and attach them to lines. Make sure that the line structure matches the shape of your Lewis dot structure. Again, if you need to rotate lines, just click at the blue dot and make it go at the top. Once you've made your line structure, please delete all the excess letters and lines. So it's just your line drawing in the drawing. So you're going to go ahead and do that for each of these, working on the dot structure first and then on the line structure. Please read for number 6 that the oxygen goes between the 2 carbons, CH3OCH3. The way that the letters are written is giving you a hint about the structure of the molecule.